Hi, in this video we are going to solve the problem 733 using DFS. We already solved this problem using BFS, and I highly recommend you to watch that video first. And we had a matrix, and we had the source of a new color that was here, for example, and we had a new color and we wanted to know what would happen to the matrix, and this would be the end result if you start from this point and try to change the color. And this one is blocked, it doesn't change the color here, you see this cell. And also we saw how we can count how long does it take to reach to all of the points. That was 6 steps, or we could say 6 minutes or 6 seconds. Now let's solve this problem using DFS. Okay, let me start with defining a class. So I have class solution, and I can call the function plot fill. I need self, greet, srsc, and new color. Okay, and we know that we can call the number of rows using the length of greet, and number of column using the length of the first row. After that, so I'm going to use a variable called old color, and I'm going to say this variable for me is the value of that grid at that source before we change the color. I say grid srsc. Okay, and I'm going to say if old color equals new color, return gray. So in a case that they just give you the same exact colors, but after that what I'm going to do is defining a function. I call it DFS, and input to that row, column, and I'm also going to import a variable d as a timer. I also want to define this d before the function as 0, because my timer starts at 0. And then I'm going to go inside this function and say if greet at point R and C equals old color. In that case, I have to change the color. I say greet R C. I assign to that new color, and then I say, okay, I need a variable to save the time. Okay, for doing that, I'm going to define a global variable x and say x equals d and d plus equals 1. Just like having a variable x that I need that to read that out of this define function, because that's the reason I'm making that global. And I'm just saying, okay, right now x is 0, and I'm going to go one step ahead, and every time I change the color, I'm going and change the x to change the d to d plus 1, and update the x for the next iteration. So then I'm going to say if r greater equals 1. It means that if my row is here, 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 so this is not before the beginning of the row, so I should go and use DFS for r minus 1, C and D. If r plus 1 is less than r, then I go and say my DFS r plus 1 CT. and if similar c greater equals 1, I say DFS, this time R c minus 1 D, and if c plus 1 is less than capital C, I say DFS R c plus 1 D. Okay, let's see what we are doing. So for each R and C that I have, I'm going to search one node before, one node after. So that was a row before, row after, column before, column after. And I can only do that if R is in that range. Is R greater equals 1? That's the only time that I can go one step back. And if R plus 1 is less than R, because I need R plus 1 here, so that needs to be in the bounding. So in that case, in all four directions we are searching. Then I come and say, let's come out of this define function, and I say let's use this DFS SRSC 0. I'm going to initialize the function with 0 and return for me grid and X. Okay, I'm going to call S1 as the instance of the class solution and print for me S1 dot fill grid SRSC and new color. So let's see if it works. So yeah, so we can see that we changed the color of the matrix as we expected. All of these, I started here, all of these things changed, and the time that it took to change that is 6 right now. So you see, if I start here, I should go 1, 2, 3, 4, 5, and 6 to reach this point. Okay, I just added some printing functions, so just to print out some middle steps to have a more clear idea of what is going on. So let's run this again and see what we are printing. Okay. So here, so I'm at this point at the beginning. So my location is here, row 1, column 1. So the next location that I'm going is R minus 1 and C. So I go one row up. So I should go to row 0 and column 1. And X, which is my counter of the time, is now 1. So I'm here now. So I'm at row 0, column 1. So it is going to search around it and say, okay, this one coming down, same thing. So X is not going to change. But it can go to what? It can go to 0, 0. It could go here. And counter turns to 2. And then it can come to R1, column 0. It comes here. Counter go to 3. And then it comes to, it searches for the above, it doesn't matter. Then it comes to R2, column 0. That is here. So X equals 4. You see, I started here and I searched all over that to here. I didn't go to this direction at all. So first I went to the left side, and that is the reason is that we are using DFS. So we go in one direction, so we are not gonna search in all directions at the same time. So then I'm reaching to that point, second row, column 0. Then it goes back. So it goes back to row 2, column 1. It searched that, it checks that, doesn't do anything. So it checks, go back. So for example, here you see we came back to R0, column 2. So what is R0, R0, column 2? That's here. So we are now back here, and you see the counter as we save is still 2. And then you go to the right and you say, okay, now here we have row 0, column 3 here. and then we have, for the next counter, we go to row 0 C4. We go to row 1 C4, which is this one, and at the end go to row 2 C4, which is this one. Okay, so in this way we are able to solve this problem using DFS, and this is our resulting matrix, and we can also count how long does it take to reach to all of the points that are connected to this source. And you see this matrix results is correct because this is also blocked with this blocked 0 cell, so the color didn't reach to that. Okay, time complexity of this problem is order of n because we might process every pixel, and space complexity is also order of n because that is the size of the implicit call stack when calling DFS. So that's the solution of the problem 733, float field using the method DFS. Thank you so much for watching this video.